Hello, this is Brandon Clayton, the Algebra Guy. Today, as you see on your screen, we'll be talking about adding and subtracting fractions with unlike denominators or with uncommon denominators. So, adding and subtracting fractions with uncommon denominators or unlike denominators. So, here's a couple of examples that you'll see us work today. Adding fractions here, subtracting fractions. And the one question I want to answer is how to add and subtract fractions with different denominators. So answering that question is just straight right out. Here's the 4 steps that you're going to see me illustrate here in just a second. We're going to find the least common denominator. We're going to convert each fraction. Let me highlight these as I go through it. So we're going to find the least common denominator, convert each fraction to equivalent form. So we did that in previous lessons about, actually the previous one before this one, we talked about how to get it in an equivalent form where the least common denominator is the same. And we're going to add and subtract the fractions from there and put it in the simplest form. So let's do it because those are just words. But let's actually see what that looks like. All right, 1/3 plus 1/2 equals, don't say, here, let me tell you first what not to do. So do not please add those 2 numbers on the top and 2 numbers on the bottom. Don't do that. This is not equal to 2/5. Another mistake I guess someone could make is just add the 2 numbers on the top and maybe pick one. I don't know, but let's not do any of those. So what we're going to do first is what we mentioned. We need to find the least common denominator between 2 and 3. So the way I talked about doing that in previous lessons is looking at all the factors for that number. Well, 2 and 3 are already prime numbers, so all you have is 2 and 3. And then we brought down those numbers 2 and we multiplied it by the other number 3, and that gives us a 6. So that's telling us that we're going to have a common denominator of 6. Well, I now need to convert 1/2 to have a denominator of 6. And I also need to convert 1/3 to have a denominator of 6. How do I do that? Well, in order to keep them equal, we need to remember to multiply a factor that is the same on the top and bottom, on the numerator and denominator. So we ask ourselves, 3 times what factor gives us 6? Well, 3 times 2 would give us 6. Well, if we multiply 2 here on the bottom, that's equal 6. So we need to multiply at the top. 1 times 2 is 2. So now we know that 2/6 is the same thing as 1/3. Why is that important? Because now it's going to allow us to add them together. 2/6 is our 1/3. Should have did the 1/2 first just to keep it in order, but it doesn't matter here because addition is commutative, which we'll talk about at a later date. You can switch the order, it doesn't matter. So 2 times what gives me 6 here? Well, 2 times 3 gives me 6. So I'm going to need to multiply the top by 3 also to keep it equivalent, and I end up with 3/6. So I'm going to keep it in the same order as we started out here. We got 1/2 plus 1/3. So 1/2 is right here, 3/6, and 1/3 is 2/6. So these are exactly the same thing. The reason that this is important, writing it this way, because now, not equals, now I'll be able to add these two. So we're doing the exact same problem. We just got 2 of the same denominators so we can actually add them. So how do we add common denominators? Well, going back to our previous lessons, we know we're going to keep the bottom the same, and we'll just add the numerator. Just add both of these up top. Well, 3 plus 2 is going to give me 5/6, and that's it. I can't reduce 5/6 anymore. We're just going to leave it that way. And our next problem, we're going to do the same thing. All right, right here, we're going to do 1/2 minus -1/4. And we notice, first thing I notice is this thing right here, minus a negative. I never like seeing this, so I'm going to go ahead and change that to, do you remember what? A positive. So I'm going to rewrite this 1/2 plus 1/4. Now I'm going to go ahead and do my next step, which is before I can add 2 fractions, the denominator has to be the same. Well, one's a 2, one's a 4. How do we find that? Well, you can intuitively think about the least common multiple between these because they're such small numbers, right? So the multiples of 2 are 2, 4, 6, 8. And the multiples of 4, 4, 8, 12, 16. And you can already pretty easily see that the least common multiple they have is 4. Or you could have went through the process that we talked about earlier and just wrote both numbers and pulled out all the prime numbers. So the prime numbers for 2 is just 2. 2 times 1. We don't include 1 because 1 is not going to count as a factor we're taking out because 1's going to be in common for everything. But for 4, we can include 2 times 2. So I notice I have 2 of these 2's in common. That's just going to be a 2. And I have another 2 right here. So that's 2 times 2. So there's another way I would have gotten 4. So I know now that I need a denominator of 4. Well, good news for us, we already have one that's equal to 4, right? So we already have one right here that has a 4. So that's just less work for us to do. So we just need to change the 1/2 to have a denominator of 4. And we're going to rewrite our problem so that it says, let's say this is the same thing as, well, we'll put it up here. So 2, how do I get this to have a denominator of 4? Well, I noticed that 2 times 2 would give me 4, and 1 times 2 would give me 2. So 2/4 is the same thing as 1/2. Now I can rewrite 1/2 as 2/4 here. And I'm going to add the same, I'm going to keep the same 1/4 because the denominator is already the same. So should be easy from this point because now we're just adding fractions with common denominators. And that gives us 2 plus 1, which you can do in your head, 3/4. There we go. So let's go back to the original. Originally we had 1/2 minus a negative 1/4. We now know that equals 3/4. All right, let's try this one here, or let's complete it. Let's do it. First, we need to find our least common multiple because we cannot add fractions with different denominators. We need to get these both having the same number. So I need to convert 7/12 into a fraction with the same denominator as 5/18. But I don't know what that denominator is yet. So let's pick our way for finding it. Yes, you could write out all the multiples of 12, all the multiples of 18, and then visually find the least one. And sometimes that could be cumbersome with big numbers like this. So I encourage you to use a method like we've been using here earlier. I'm going to write this lower, keep our space open. So we're going to put 12 here and 18. So let's look at the prime factors. I'm going to make a note here just in case you needed a reminder from a previous lesson. These are the prime factors we're going to pull out for 12. Well, to get 12, you can do 6 times 2, 4 times 3, but whatever you do, it's going to give you the same prime numbers. And I'm going to pull those out now. Let's think of 4 times 3. Well, 4 is not prime because it has a multiple of 2 in it. So I can take out 4 and make it 2 times 2. And so that's my 4. Now I need to do times 3. So this represents my 12 in prime numbers. That goes back to a lesson called prime factorization. And 18 can be represented with 9 times 2, 6 times 3. No matter what you choose, it comes back to the same thing. So 9 is not prime, but 3 times 3 gives me 9, and those are prime. Actually, let me write this so that the same numbers are under each other. So 3 times 3. Notice I kept that 3 under each other. So that's 3. That's 9, and I have a 2. So this piece represents my 18 if I multiply it together. 2 times 3 is 6. 6 times 3 is 18. Or 3 times 3 is 9. 9 times 2 is 18. So no matter how you slice it, you get the same number. But now when I look down, I notice this 2 is going to be by itself. These 2's can come down for itself. I'm going to multiply. These 3's you can bring down as 1, 3. And this 3 you can bring down as 1, 3. So whatever this adds up, or actually multiplies, and whatever this yields as a product will be our answer. 3 times 3 is 9. 9 times 2 is 18. 18 times 2 is 36. So we need 36 to be our least common denominator. So let's find out what the top numerator has to be. 12 times what gives us 36? Well, that's 12 times 3. So we need that same 3 up top. And 21 over 36 is the same as 7 over 12. 18 times 2 gives us 36, so we keep that same factor in the numerator. 5 times 2 is 10. So now we can rewrite our expression here. Instead of 7/12, we're going to write 21 over 36 plus, instead of 5/18, we're going to write our new fraction, the equivalent fraction of 10 over 36. And this is so much easier to do because we have like denominators and it's easy to add those. Just keep the bottom the same and add the top together. 21 plus 10 gives me 31 over 36. And there we go, that's it. And that's it, because we can't simplify 31 over 36. There's no factors for 31 that are the same as 36 other than 1. So 31 over 36 is our answer for this right here. Now, before I go to my next problem, again, I want to reiterate why it wouldn't have worked for you just to go straight across, right? If you would have went 7 plus 5, that would have given you, let me put it in red just so that you know that's wrong, not to do that. All right, don't do the following. All right, so you would have written 12 over 12 plus 18, which is 30. You can reduce those because that has a 2 in both of them. And a 3, so let me use a 3. 12 divided by 3 is 4. 30 divided by 3 is 10. I can still divide by 2, give me 2 and 5. So this is 2/5. So someone may get excited, and believe it, if it's multiple choice test, they'll a lot of times have answer choices just like that, and students will get excited because they did some work, they see their answer, they're like, yes, I got it, but it's not the right answer. So don't fall for that trap. Get your denominators the same before you move to your next problem. All right, so let's just subtract these, and I want you to pause it and work these as we go, please. So I'm hoping you're pausing it here and attempting it before I do. All right, first thing we need to do is get a denominator that's the same, because we can't subtract or add with different denominators. So I need to rewrite this. I'm going to bring that negative to our 19 so that one of these gets the sign. But I need to make this equal to some fraction that has the same denominator. So how we do that? We're going to do it the same way we've been doing it. We're going to take 15 and find the prime factors for that. And we're going to take 24 and find the prime factors for that. So 3 times 5 is pretty easy. Those are my 2 prime factors. 24 can be broken into, let's think, 12 times 2. So I know there's a 2. And that 12 can be broken into 4 times 3, which is oh, you know what? I heard that 3, so I need to get this 2 over to the side so there's nothing here. But I forgot. Let's do 2 numbers in the middle. Let's do 8 times 3. So 8 times 3 can be broken. This 8 can be broken into 2 times 2 times 2. So that's 8. Now I got to do times 3. Well, the 3 is right here. So this represents the factors of 24 and the factors of 15. These are all prime. Now I can examine them. I look up this column here and I see we got a 3. I look up this and there's nothing but a 5, so times 5, and nothing but a 2, 2, and 2. So when you multiply all those together, we're going to get our like denominator, or least common denominator. 3 times 5 is 15. 15 times 2 is 30. 30 times 2 is 60. 60 times 2 is 120. Oh my goodness. So it's so good that we have this method, because did you really want to count all the way up to 120 by 15s? No. You could, and it wouldn't take extremely long, but it's just not fun. It's not worth it. This is a much simpler method to kind of just look at real quick. As a matter of fact, you can do a lot of this in your head when you kind of start visualizing it. Well, maybe not this problem, but some of them. All right, so now I need to find my equivalent fraction, fractions to 7/15 with a 120 as a denominator. To do that, I'm going to ask myself the question, 15 times what gives me 120? What's the factor that goes in between that I need to use for the numerator and the denominator? So 15 times what? Let's think. 30 times 120 is 40. So this is probably going to be 8. So 15 times 8 gives me 120. So I know that this is times 8. And you could just divide in your calculator if you want to, or even by hand to get that number. Or just guess some numbers. Just keep going up. 15 times 5, 15 times, find that factor. And we're going to multiply the top by 8. It gives us 56. I'm going to erase this because I need this space. And 24 times what gives us 120? We've done this one before. 24 times 10 is 240. Half of 240 is 120. So instead of 10, I can say times 5. Whoa, times 19. What is 19 times 5? Well, 20 times 5 is 100. 100 minus those 5 groups will be 95. And I'm going to have to keep that negative here. And I'm going to double check that, right? Because I just kind of quickly did that in my head. 19 times 5 is 45. 5 times 1 is 5 plus 4 is 95. So, yeah. So now, instead of 7/15, we are rewriting this so that it says 56 over 120. Minus, so we already have our minus here, minus 95 over 120. And we're going back to remembering our integers. When we have 56 taking away a bigger number, this is going to be a negative number over 120. So what is 95 or 56 minus 95? Well, whatever that subtraction is, I'm just going to do 95. Let's just do it over here. 95 minus 56. We're going to make that a 8, 15. That's a 9. 8 minus 5 is 3. So this looks like 39. Let me double check that. 8. Yep, that's good. So that's 39 or negative 39 over 120. I'm not done because I'm looking at these numbers and I can tell they can be factored. Why? Because, yeah, I'm pretty sure. Because when you add up 3 and 9, it gives me a multiple of 3. And when you add up 120, the numbers in 120 gives you a multiple of 3. So I know they can be divided by 3. So we want our answers simplified as much as possible. So I'm going to make some space to do that. Let's erase some of this. And we're going to divide 39 by 3. Look, oh, you know what? Here's an easier way for you to see that. So let's rewrite this because I know there's a 3 in there. So I'm going to take my 3 out. Let me get that 3 off this line. So I'm going to take that 3 out here times 13 because 13 times 3 gives me 39. And for 120, I know there's a 3 in there. 3 times 40 gives me 120. So just looking at this, I can already tell that I can factor out a 3 like I was saying, and that leaves me. So instead of, that was such an easier way. I was going to do 39 divided by 3 and then 120, but this is so much nicer. So I'm glad I did that instead. So that leaves me with a negative 13 over 40. Now I'm looking at these two, and 13 is a prime number, so I know it's not going to be able to take anything out with 40. So this is as low as we can go. So both of these are correct. However, this is the ideal answer because it's simplified, it's reduced, it's brought down to its where the numerator and the denominator have no common factors other than 1. All right, so what about this one here? Those are some big numbers. So this is another reason why you don't want to sit there and go 30, 60 and try to take all those out. So let's deal with these. Let's get our prime numbers from these. And one way to, actually, I know what I'm going to do. Show you another method that we've used previously. So going back to what we said before, we can add these. Why? Because we have different denominators. Good, I'm hoping you said that. Different denominators here. And 23 over 42. I don't like to write in red, so I'm going to switch up colors here. All right, so now my question is, so you notice I put this negative with the 11, by the way. It's easier just to put it with the numerator. I need a common denominator. So one of the ways you can do is 30, 60, 90, and put all your multiples of 42, 42, 84, and all that, and try to see which one. But obviously this is going to take a while, and it's going to be huge numbers. Another way you could do this is to break it down into this prime numbers. And let's do it this way. So the way we've been doing it is we've taken our 30 and we've broken it into its prime numbers, and our 42 and broken into its prime numbers. So we'll take 30 and we'll do 3 times, was it 10? So that'd be 5 and 2. Or we do 42, and I know there's a 3 in there, times what is that? Well, I should have used a bigger number. So let's say 6 times 7. Yeah, 6 times 7. So 6 times 7 is 3 times 2. Here's a 2. And times 7. Actually, that's the easier way. I was going to use a tree, factor tree, but this actually probably is easier. So this is a 3 here times 5, and I have a 2's here times 2 and times 7. This is so much quicker, man. So what I was going to do is do 30 and start breaking it down into some factor trees. So break these 10 down to 5 and 2, and then you see your factors there. And do the same thing for 42. 42. So when the numbers start getting big, you might want to consider factor trees. Sometimes that's visually easier on you. So I was going to do 3 or 6 times 7. Breaking these down, 3 times 2. So the end of your trees are these little buds, and those are your factors. So it's the same factors you see us having when we did it this way. So now we can multiply the factors that didn't show up or in the same column. And that's 3 times 5 is 15. 15. Oh, you know what? I better start with this big number. 7 times 2 is 14. 14 times 3 is 42. And then 42 times 5, oh my. 42 times 5. I'm going to guess that it's 210. 5 times 4 is 20. Yep, 210. All right, so wow, look at that big number, 210. And we want to know how many times 30 goes into 210. 30 times, looks like 7 times 7, they give me a negative 77. And how many 42s are in 210? Well, that looks kind of tough, but then I think about it. 42 times 10 is 420. Half of 420 is 210. So I know this is going to be times 5. 23 times 5 is the same thing as 20 times 5, which is 100, plus 5 times 3, which is 15. So 115. And you can just work that out by hand if you did not follow that. So what am I going to do now? I'm going to replace my negative 11 over 30 with, this is the same thing as negative 77 over 210 plus 115 over 210. Now it's much easier. Why? Because my denominators are the same. 115 minus 77 is what I'm working with now. Actually, I like to add. So what do I need to add to get to 100? So I need to add 23 to 77 to get to 100. So 23 plus 15 is what I'm looking at here. 23 plus 15 is 38. So this is going to be a 38 over 210. So I usually like to add instead of subtract. It's just easier in my head than going through and trying to subtract. So just add up from 77 to 115. That's 23. Just want to make sure. And 15. Yeah. So 38 over 210. And we're almost done. But we did not simplify because I can see that these are both even. So I know they at least have a 2. Can they have anything? 8, 19, 11. At least has a 2 in it. So if I would have taken a 2 out, 2 times 19. And 2 times half of this is 105. 2's crossed out because 2 divided by 2 is 1. And I'm left with 19 over 105. Now I'm done. How do I know? Because 19 is a prime number. So there's nothing in 19 that's going to factor out with 105. Wow. What a great problem. And I hope you were able to follow that. I believe you were. All right. So again, this is our last problem. We got a variable this time. How are we going to handle this? Let's take these two. These look pretty simple this time. 3/5. We need a common denominator. And x over 8. Please don't be thrown off by the variable because they do that a lot of times to make sure you understand how to do it, not just trying to get some numerical answer. We're still going to get the least common multiple between 5 and 8, and we're going to use our same method, right? So we're going to take the factors of 5, which is just 5 times 1, and then the factors of 8, which are prime, which is 2. Actually, let me put it by itself. 2 times 2 times 2. So really, all we're doing is multiplying 5 times 2 times 2 times 2. 5 times 2 is 10. 10 times 2 is 20. 20 times 2 is 40. So now I know I have a 40. And now I can get my numerator by saying 8 times 5 is 40. So x times 5 is what? 5x. Please don't put 5 plus x or anything like that. It's going to be 5x. And don't put x5 because x5 is not the right etiquette, algebraic etiquette, if you will. They're both multiplying, but you want to put the number first. All right, so up here we're going to do times 8. So up here we're going to do times 8, and that's 24. Now I rewrite my 3/5 to be 24 over 40. And plus my x over 8 is now 5x over 40. And I'm going to add those two. 40 stays the same. I got 24 plus a 5x. What else can I do to that? Absolutely nothing. Because we got a variable up here with the 5. These are two different terms, so I can't say 29x. Please do not say 29x. No, because you can't put the 5x's with the 24. Those are unlike terms, and you're just going to keep it just like this. This is our perfect answer. All right, guys, thank you so much. How to add or subtract fractions with different denominators. Wow, what a big lesson, but very, very important because you're definitely going to see that continue to come up, and I want you to have the confidence to work it. So did we answer our one question? Absolutely. It took us a few minutes to do so, but we definitely answered it. Thank you for tuning in. I'm Brandon Clayton, the Algebra Guy, and I will see you next lesson.